In 1997, in a room in New York, chess grandmaster and reigning world champion Garry Kasparov held his head in his hands as he realized he was losing a chess match, not to another grandmaster, but to a computer called Deep Blue.
And whoa! Deep Blue Kasparov, after the move c4, has resigned.
For the first time, a machine outperformed a human at a game long considered to require a signature of human intellect: strategic thinking. It wasn't the birth of modern artificial intelligence, but it was a symbolic turning point. Deep Blue didn't learn, it didn't adapt or dream up new moves. It followed rules, millions of them, sifting through possibilities with really technical precision. It was a brute force kind of victory, but its victory did reveal that intelligence could be encoded and externalized. Now, I love chess, but I'm happy to admit that most machines, and also definitely a lot of people, are better at it than I am. But that's not the point of the game. Deep Blue doesn't mean that we've solved chess and never need to play it again. But it does illustrate an example of a tension at the heart of how AI is perceived. When a technology so seems to mimic, in various ways, the things that we think make us human, it can become the source of existential worry. On the other hand, modern AI systems are also revolutionizing how we do science and have the potential to absolutely transform our lives. Now, from rule-based AI like Deep Blue, we've moved to systems that no longer need explicit instructions. Today's AI learns patterns instead of just memorizing rules. In the 2020s, there's been an AI boom and a huge surge of interest in AI, as generative AI applications like large language models and the people and companies behind them continue to make headlines and capture our imaginations.
Hi, I'm Tilly Norwood, the world's first AI actress, or, as some might call me, the end of civilization.
This boom can be traced back to 2012, when Geoffrey Hinton's group at the University of Toronto used deep convolutional neural networks to win, by a large margin, an annual computer vision competition. And one of the things I've been thinking about as a curator is, how can a museum make sense of a topic like AI? It's one that has a lot of intangible, immaterial aspects to it, and one where the software that we interact with and how we interact with it is currently far more significant to us than the physical hardware, the stuff that we can put in museum showcases. The museum has a world-leading collection of the precursor technology to AI, from mechanical looms to Lovelace, Babbage, and Turing, and further to ARM chips, Wizard, and beyond. We'll be hearing from leading academics from universities around the UK about where AI came from, how we use it, and the stories we tell about it. First, let's dive into the present-day thinking around computing and algorithms, around what we mean by intelligence and consciousness, and so try to piece together what on earth artificial intelligence actually is.
AI is code, code is just algorithms, and algorithms, frankly, is just mathematics.
AI is artificial intelligence, which usually refers to a system that's artificially built and usually not built out of biological material that we consider intelligent.
I'm going to quote something attributed to Geoff Hinton at this point. It's when you get a computer to perform a task by showing it what to do rather than telling it what to do. If you want a computer to recognize a picture of a cat, then you might say, well, it's got to have whiskers and it's got to have pointy ears and a tail and fur. Whereas showing it what to do is like, I'm going to give it a whole bunch of pictures of cats and then say, look, you figure it out.
There is a textbook definition of what AI is. In the words of Margaret Bowden, computers that do the sorts of things that minds can do. So the term artificial intelligence was invented in 1955 by John McCarthy, a computer science pioneer who wanted to run a summer workshop at Dartmouth College on computer science problems to do with human intelligence that he thought could all be solved in one summer. Spoiler alert, he couldn't.
The term artificial intelligence is hugely provocative, partly because of its legacy in science fiction. There's always been this dream throughout human history of creating artificial versions of ourselves. which you can trace back in human culture, as long as you want, back to the golem in Jewish folklore, which was made out of mud from the banks of the Tava River, to Dr. Frankenstein creating his creature from parts of living bodies.
It's alive! Oh, it's alive! It's alive! It's alive! It's alive!
That dream has been a guiding force in AI, but it's also a misleading description of where we are and where we might be going.
In a study that I have done, I got replies to the question, what do you think AI is? Where people said, scary robots, or the Terminator is going to be real one day. It shows that what people think AI is and what AI actually is can be quite different.
One of the deepest confusions, I think, about artificial intelligence is the relationship between the biological brain and a computer. Now, the brain has always been really challenging, opaque in its complexity and its mystery. And when we've tried to understand how it works, there's always been this temptation to reach for the dominant technology of the day as a metaphor. Over a century ago, people thought of the brain as some kind of system of plumbing, and then it was a telephone exchange. And since around the 1950s, it's been thought of as a kind of meat-based computer.
Today, researchers tend to distinguish between general intelligence and narrow intelligence. So narrow intelligence is when you are good at a very specific task. So I might be good at chess or the very difficult strategy game Go. But if I can't extend those skills to other domains, then we would consider it a narrow form of intelligence. General intelligence is defined today typically as the ability to solve a wide range of problems or achieve one's goals in a wide range of environments or situations. So it's not limited to one domain. One might ask, are machines generally intelligent in addition to having these special superhuman skills? And it's not clear that they are. They have not shown themselves to have general intelligence yet. One of the challenges of identifying intelligence in other animals and in AI is that sometimes behavior may appear intelligent when, in fact, there's something else going on under the surface.
Alan Turing's famous test, the Turing test, is supposedly a test of machine intelligence. And in practice, it asks whether a human being can tell the difference between a machine and another human being, when both of these things are pretending to be a human being. And the idea is that when a system or machine can pass this test, then it makes sense to speak of it as intelligent. But it's really a test of what it would take for a human to attribute a property to a system, in this case intelligence, not a test of whether the system does indeed have the property in question. So you could say that the Turing test, rather than being a true test of machine intelligence, is instead a test of human gullibility.
I think what we're seeing is not intelligence which is like human intelligence, but actually something which is a very different sort of intelligence which is being developed. So machine learning is the idea that code can learn. Machine learning is code that starts very simply and then it's tasked with perhaps recognizing what is in an image, and it's then given lots of data, and it starts to then produce a set of instructions which, it asks questions of a new image, but every time it gets it wrong, it then changes the code, and this is the learning process. The code is actually changing and mutating as it interacts with data. And this is partly the reason why we've had an explosion of AI in the recent period, because we have a huge amount of digital data for it to learn from. That's really been the fuel, the oil, this data, which has created the power of the AI, which has materialized out of machine learning.
In order to understand a technology, it can be useful to compare it to others. We're in the Science Museum's Library and Archives in Wiltshire, where, among other things, we hold a large collection of papers relating to Charles Babbage. Babbage was a mathematician and inventor born in London and famous for his work on different calculating machines, which in many ways are analogous to modern-day computers. But right now, our focus isn't on the difference engine or the calculating engine. It's on these letters written by a woman called Margaret Seymour to Charles Babbage between 1849 and 1864. Nearly 200 years ago, Margaret Seymour made these marks on these pieces of paper, and when she did so, she recorded her thoughts, so that when Babbage read them, the thoughts were beamed from the page through his eyes to his brain, so that he could understand and know those thoughts without her being there. And if you can decipher the handwriting, we now have this enduring record of those thoughts that we can access today. Reading and writing is an example of a remarkable technology, and one that can help us think about AI. Writing is an outsourcing of human memory. When we write something down for later use, we're offloading the work of memory from the brain to the page. These cuneiform tablets from ancient Mesopotamia are business documents. Tablets like this would have been written around 4,000 years ago, and literacy goes back even further to 6,000 years ago. Reading and writing is something that we have to learn to use. If we don't understand it, then written language is meaningless to us. But once we do learn, we gain access to an entire recorded realm of words and thoughts and meanings. Some of the ancient Greeks, like Plato, were skeptical of writing, as their culture moved tentatively from oral to written. They thought that it would make you forgetful, that it would make you lose your memory, that you wouldn't get to the truth as the author intended, but only a semblance of the truth. We do see generational shifts, with certain skills falling out of favor as new technologies are introduced, such as one generation being able to read maps really well, and the next being almost entirely reliant on GPS. Our technologies build on the components of other technologies. It's easy to draw a line from the written word to the printing press, to word processors, to the explosion of written culture on the internet, which is now, for better or for worse, informing large language models. How we use these technologies in turn affects how we think. Philosophers Andy Clark and David Chalmers in the 1990s argued that our mind is constantly extended beyond our bodies and interacts with our technologies. We know that intelligence is difficult to define. So is AI outsourcing intelligence for us, or even attempting to? More importantly, there's a discussion to be had around the power and consequences of these technologies and the active role they play in shaping how we act and think.
Tools are part of being human. So initially it was just the idea of tool use. So humans use tools, that makes them different from other apes. Of course, now we know that chimpanzees also use tools.
In Central Africa, chimps crack nuts with rocks. In East Africa, they catch termites using twigs.
But of course, chimpanzees use tools in very different ways, and most importantly, they don't build on those tools to make better tools to radically change their surroundings, their society in the ways that humans have. And in mythologies around the world, you see this idea that having tools, having these kinds of technological skills somehow make us special. So in Greek mythology, you have the idea that Prometheus gave humans fire, stolen it from the gods in order to give humans a fighting chance against all the other animals that had claws and teeth and wings and so on. Technology makes humanity, so all our technologies are part of our humanity. So our phones and our computers and our smartwatches and whatnot are. And to some extent, you can see where that's coming from, because technologies do change who we are and what we are able to do with them, but also without them, because there's a constant skills trade-off when we encounter new technologies.
People are using AI actually all the time, even though they may not realize it. So, for example, recommender algorithms, the fact that Netflix might recommend a film for you or Amazon a new book, that's based on an understanding of what you've put in as data beforehand, and it will offer something bespoke for you. There is kind of a difference between using a calculator or using this kind of new emerging AI, because the calculator, we sort of understand what it's doing because we wrote the instruction for how the calculator works. And I think the real challenge of this new AI is the trouble is that we do not understand quite how it is making its decisions, because the code that's emerged out of this learning process is so deep and complex. Just looking at it isn't really helping us to understand how it's working.
So an LLM, you can describe it very simply. It's a machine to predict the most likely next word that a human would use after seeing all the words so far. And so this seems like a very simple task, right? You know, I caught what's the next word? So I caught the bull, that would make sense. And I caught the fish, that's another likely next word. But I caught the house, I'd be quite baffled if I heard that sentence. But then you imagine that you've trained yourself on everything that humanity has ever written. And so this idea of predicting just the next word ends up being incredibly rich. In certain instances, this might not be necessarily a fact. Famously, when you prompted LLMs something like, tell me about the famous physicist, and then you invented a completely random name that no physicist had, rather than saying there's no physicist of that name, it would then say, yes, that person was born in Heidelberg in 1938, they studied in Berlin in 1955, etc., etc. It'd invent a whole life story for this non-existent individual, because this is a plausible sounding thing that a human would answer. So once an LLM's been trained, it needs to be taught to behave itself. So this happens in a second phase, which is called reinforcement learning with human feedback, where many, many humans act to have LLMs learn to be well-behaved and civil and not reveal any sort of dangerous information that they shouldn't.
More recently, we have a lot of things like generative AI being able to make things for you, text or visuals. And that, again, is based on learning the things that you like creating and making more of the same. There's a real challenge about whether artificial intelligence can be genuinely creative. We're certainly seeing incredible apps that are generating portraits in the style of Van Gogh and things like that. But all of those are just pattern recognition and pastiche. It's not really, genuine creativity out of the machine, or actually composing music. A wonderful example of a jazz improviser, Bernard Lubat, who trained an AI up on his musical style. The AI started to show him new things that he could do with his style of music. He said, I recognize that, but I've never thought of doing that before. So that's one of the exciting challenges, that AI may stimulate us to do new things with old data. Although it was fun to listen to kind of in the short term, over a few minutes, it was playing something which was quite interesting. After about 5 minutes, it became boring because it didn't really know where it was going. It didn't have anything to say. And I think that's one of its limitations, that AI, it doesn't have intention or agency. It is basically a statistical tool, which it doesn't understand that sense of time that we have. I think this technology is not just a development of things we've seen before, but is a real phase change. It's a bit like, the car was not just a development of the idea of a horse. It actually was doing completely different things, just in the same way as things happened in the Industrial Revolution during Victorian times. It changed the way we do things. And if people don't recognize that, they're going to be left behind.
So we can view AI as a tool, but it's also viewed by some as something that could bring about the end of what makes us human. To make sense of AI further, we should think more about what's revealed by AI narratives. There are two threads to pick apart here. One is stories about AI, and the other is stories, or more broadly, works of art, by AI. What can the first tell us, and what does the second say about what we're afraid of? I'd argue that when we look at the suite of hotly debated science stories that are around today, AI is the one that is the most influenced by popular culture, more so than climate change or current space science, both of which generate compelling images from real life. Our image of AI is dominated by the visuals and narratives present in science fiction. If you're a lover of sci-fi, you'll probably have a favorite book or film that deals with an encounter with the other, and this other, when not being an alien, is often an intelligent machine, a technology. The Science Museum has a history of collecting and displaying these machines, especially humanoid robots, where people have attempted to make machines like us. These stories are important because they can shape and guide the trajectory of the technology. While creative works about AI are one thing, seemingly creative works by AI are another. In George Orwell's novel, 1984, he describes a machine called the versificator that composes songs without any human intervention whatsoever. There's also a machine that writes novels.
From the age of Big Brother, greetings.
How will the important issue of tech companies who are accused of extracting the creative labor of artists whose copyrighted works are being used to train generative AI, most often without their permission, be resolved?
極めて不愉快ですよね。そんなに気持ち悪いものをやりたいなら勝手にやってればいいだけで、僕はこれを自分たちの仕事とつなげたいとは全然思いません。たどり着きたいです。人間が描くのと同じように絵を描く機械を作りたい。はい。
What is the purpose and worth of an AI-generated work of art? Do we fundamentally require art to be created by a human being, someone as imperfect as ourselves, to find meaning in it? These generative AI models evoke fears that differ from those raised by other AI advancements. To clarify this distinction, let's consider AlphaFold, an AI system developed by DeepMind with its successful second iteration released in 2020. AlphaFold predicts the three-dimensional structures of proteins, solving a serious challenge in biology that previously required years of lab work per protein. It's enabled faster drug development, improved understanding of diseases, and has already contributed to over 200 million protein structures that are now publicly available. But AlphaFold doesn't speak to us. It doesn't engage us in any human-like interaction or activity. It doesn't tell us stories. It's still an AI, it's really the same thing under the hood, but it doesn't raise concerns about creativity, identity, and control. Perhaps when it comes to AI narratives, they can prompt us all to ask, what is it that we actually want from these AI systems?
So lots of technologies actually exist in our minds long before they exist in our hands. Many technologies start as stories and then eventually get built because we want them so badly.
Spock.
And so AI is one of those. People have been imagining AI for literally thousands of years. But those people who were inventing or imagining automata that could move like humans, could move like animals, they would never have imagined ChatGPT.
The robot is called Miss Honeywell, presented as the ultimate in automation. The compere of this show tells his audience that Miss Honeywell would make a good assistant to any sales manager. He, she, or it replies, "Assistant, nothing. I'd make someone a very good wife."
We looked at the gender of AI creators in 100 years of influential films in Hollywood and beyond. We did not find any female AI creators until 1997.
I have created the ultimate weapon to defeat Austin Powers. Bring in the fanbots!
And in total, we looked at 150 films. We only found 9 women.
I think that one day, artificial intelligence is going to kill us all.
My AI isn't like the movies, Mother. It does exactly what I tell it to do.
Yeah, if only children were the same.
The idea of the male creator, especially of female AIs that do his bidding, is one that we saw returning again and again throughout film history. So starting with Metropolis in 1927, films like The Stepford Wives, where a male roboticist replaces all the women in a small town with more perfect robot women. More recently, Ex Machina, where a tech bro secretly builds several AI women, discarding old prototypes, even though they seem to be fairly sentient.
Go back to your room.
You see often the AI being put inside a kind of robot body. If you think of Ex Machina, there was absolutely no reason for that AI to be put inside a beautiful female-looking figure. But as soon as we see that, we then attribute agency to everything it does, because we get tricked into thinking that this is somehow something very human-like.
An AI doesn't need a gender. She could have been a gray box.
Actually, I don't think that's true. Can you give an example of consciousness at any level, human or animal, that exists without a sexual dimension?
Consciousness is incredibly hard to define, which is sort of odd because it's the most familiar thing to each of us. And consciousness, very roughly, is what goes away when you go into a dreamless state of sleep in something like general anesthesia. Another way to think about consciousness comes from a philosopher called Thomas Nagel, and he said that an organism has conscious mental states if there is something it is like to be that organism. But for some things in the world, there is nothing it is like to be that thing. For a table or a chair, they're just objects. There's no inner world. Fundamentally, consciousness is about the presence of any kind of experience whatsoever. We tend to project qualities into other systems on the basis of what might be only superficial similarities. We do this all the time. If something has a smiley face, we'll project an emotion into it.
Does it speak? Will we understand it?
Well, it depends upon what aspect of your language has survived over so many thousands of years.
Emoji! It speaks emoji!
Of course it does.
But if something speaks to us, that tends to be a really powerful seducer of our intuitions.
I think you know what the problem is just as well as I do. This conversation can serve no purpose anymore. Goodbye.
And that's the final bias that we have, which is this idea of human exceptionalism. And language feels to many of us like the pinnacle of human exceptionalism.
I've been doing a lot of work on how people see AI. Literally, when someone creates a picture of what an intelligent machine looks like. But I noticed that simply typing intelligent machine into Google just led to pages and pages of white plastic androids doing all kinds of things. Why is it that people want to depict AI as a white plastic android? And what does that mean for the assumptions that people make about what does an intelligent creature look like? The answer seemed to be, it is something that is white. And it's not until you see artwork of an android that is deliberately made to look black, with coiled hair, with black facial features, that you notice how big that difference can be.
A lot of science fiction is cautionary. It's warning us against the possible consequences of untrammeled technological development. One of my favorite science fiction stories of this kind is actually Frankenstein. What mattered in the story of Frankenstein was not that Frankenstein's creature was alive, but that it could feel. It was the capacity for consciousness that led to all the carnage that followed. If we confuse ourselves too easily with our machine creations, we will end up not only overestimating them, but diminishing ourselves and underestimating what it is to be a living human being.
When you start developing technology that can do something that humans could formerly do, but better, like navigating, and you develop another technology that can do several things that a human can do, but better, that is where people say AI will go. That is what artificial general intelligence is going to be. This machine that can do everything that humans can do, but better.
I think we overestimate the likelihood that AI will become conscious along the trajectories it's going now, but that doesn't mean it's impossible. Our brains, our embodied brains, are able to generate conscious experiences. So the real question is, how brain-like does an AI system have to be in order to move the needle on the prospects for real artificial consciousness? If and when that happens, then we'll enter a new ethical and moral landscape altogether, because as soon as something is conscious, it has its own interests and not merely the interests that we humans give to it.
A development that I think AIs really need is this ability to experiment in the world and this ability to learn from what they've done. There are some domains in which AIs are obviously very good, but there are others in which they're still quite far behind, most notably where AI is required to act in the real world. I think, on the other hand, a little more deeply, like AIs need to perhaps learn to meet us where we are. So we communicate very slowly, but we have this very rich interior life. So, hopefully this might be a direction for AIs to go in the future. Once they've learned to model other humans, they might turn that skill on themselves and gain consciousness, but we'll see if that happens.
One of the risks with machine intelligence is that intelligence has a evaluative dimension. We tend to think of it as good because we tend to think of machines as tools that we have the freedom to choose how to use. We might not recognize that, in fact, they can embody values or have values embedded in them. And if we think of machine intelligence and intelligence as good, we might think, well, machine intelligence is just clearly good for society. But in fact, it might not be. So we need to be careful there.
I think there's a lot of worry about AI kind of wiping us out and taking over. But I think actually the way we need to see this is that we're actually going to become AI. I think it's already happening, that we're using technology very much as an extension of our bodies. So I think we're going to see a lot more of AI being incorporated into the way we do things in a kind of physical way, kind of speculative ideas of things like Neuralink, that we're going to have this kind of technology introduced into our brains. I don't see why that won't be part of our future. So maybe we shouldn't be frightened of AI because we may have the possibility to fuse and become AI.
The story of artificial intelligence is often framed as machines edging closer to becoming like us, but that framing misses a more revealing angle. What emerges instead is a story about how human beings keep extending ourselves, first through language, then through data, now through code, with each step projecting more of human thought and behavior into external systems. For most of human history, tools have amplified human capacities rather than strictly replaced them, and the hope is that AI fits into that longer pattern. However, the anxiety that was realized with Deep Blue, that fear of outperformance in a very human domain, that's there as well alongside the hope, because this can and will have ramifications for real-world things like jobs, mortgages, healthcare, whole industries. But we needn't see AI as an external intelligence arriving from outside, but more a crystallization of human choices, what to measure, what to optimize, what to ignore, what to value. Each AI model embeds decisions that originate with people and institutions and cultures rather than with the machines themselves. The systems reflect back our metaphors, our categories, our blind spots, all these especially from louder voices on the internet, as well as our intrinsic desire to see agency and mind wherever something responds fluently to us. Our technology's got to the point where it has profound consequences for us and for the planet in really big ways. We can feel like we're occupying a confusing moment in time when the predicted futures of techno-optimists and techno-pessimists could both equally be on this threshold of being realized. We can use it as a moment to study our own values and ambitions and decide what we're willing to encode into the tools that will, in many ways, reshape us in return. I think it will be important not to forget the very human trait of empathy while we busily go about preparing ourselves to interact ever more effectively with these tools that we are continuously compelled to make.